Ah, so good morning. So I'm Fernando. So welcome to our coffee break. So I got my coffee here. So I got a double shot coffee. So I'm good to go. So I appreciate you taking the time to this morning to participate or at least to watch this coffee break. What we're gonna be talking about today is gonna be about SEC on pipeline. So that's one of the things that lately I've been discussing with different people. So there's a lot of owner operators that are on the pipelines, and they're having a lot of stress corrosion cracking problems. So one of the things that has come onto the market lately is the TFM, and that's pretty much what we're going to be talking about today. So what we're going to do is go. I want to show you a PowerPoint that goes over just the basic theory, and then we're going to go into the equipment so you can see. So should be good. So let's go through a few slides here. So just about my background. So I'm a level three. I got my level three in ultrasonics back in 2012. But just like most of you maybe have experienced before, so I fell into the industry. So I didn't go out looking for NDT. Uh, it seems like it found me. So I started it back in 2001. So I was actually repairing and calibrating the equipment, and then so I did that for like 7 years, and then I transitioned more to like a support role for the equipment. So I actually come from the Nordic and Sonic side. So I'm not sure if anybody out there has worked with the Nordic and Sonic equipment, but if you have, go ahead and comment on it. So I want to try to get your participation as we go through this thing. So and then so I was more on the support role, and then so I did that for like 5 years, and then I moved over to be an instructor. So I was an ultrasonics instructor for 8 years, and then I switched over here to Eddyfi in January. So the technology is coming up. So I want to applaud the my colleagues up in over in France. So the 3.2 software has come at leaps and bounds compared to the what it started off with. So that's what I want to show you today. So let's go and go through some of the theory on this thing on the TFM side. So some definitions are important. So we got TFM. So there's a two-step process. So we got data acquisition is going to be what we call FMC, which is full matrix capture, and then we have data reconstruction, which is the TFM side. But now the technology and the speed of the processors, you can actually do TFM live. So it makes everything a lot quicker. So I'm going to go through the theory as far as some of the functions that the equipment does. So FMC is done on using standard phase array probes with or without a wedge. So you can do it with the looking for corrosion, or you can also use an angle wedge or a flat wedge. So right here you see a probe. You have some sidral holes, a block, and then this is what it's gonna do. So we're gonna be talking about full matrix capture. So with this, it fires one, as you can tell. It hits the reflectors and then it reflects back to the probe. So as you see on the image to the right, so we have on the left side we have receivers, and then we have emitters on the right side. So then that was number one. Then it's gonna fire number two, sends the signal, and then it's gonna receive with all the elements in the probe. So then it fires number three. It hits the reflectors, reflects back to the transducer, and it keeps on going through the however many elements you have. So this is the last one. It reconstructs the whole thing. So that's the processing for all of them. But depending on how many elements of the probe you have, so that's going to tell me how many. That's going to tell you how many signals you have. So if you have a 16 element probe, the number of signals that it's going to process is 256 signals. So if you have a 32 element probe, it's going to be 1024. If it's 64, it's 4096. So this is pretty much what it's doing. So what it does is actually focuses within that region of interest. So we call it the ROI. So that's another term that you might hear in the industry with the TFM side. But we can adjust our parameters depending on where you want to focus at. But it's pretty much doing this. Fairly straightforward, so you get a lot better imaging. So that we also have another technology called plane wave imaging. So what that actually does is imagine phased array where you're pulsing all the elements and receive. In this case here, you're receiving with all the elements. So you pulse with a certain amount of elements, you receive. It's pretty much like a sectoral scan. So it's gonna fire. In this case here, we'll say it's 8 elements or 16. It goes in one at one angle, sends, receives, then it switches to another angle, sends, and then it receives the information back to the transducer. Sends again, depending on how many angles you have. So I'll show you the difference between what the difference is between the FMC and the PWI. In this case here, so what do we get? So for example, if you use the 64 element probe and perform the 35 to 70 sectoral scan with an angle step of 5, we have 8 angles throughout those angles, and it processes 64 times, so you get 512 signals compared to FMC, which is 4096. There's a drastic decrease in number of signals to process using PWI. So one thing that's going to happen is, since you don't have to process so many signals, you can scan faster. So scanning speed. So one of the things that FMC gets downgraded on is going to be the speed. But so there are things that you can do to increase the speed depending on the unit. So that one of the things is the number of elements in the probe, number of pixels, and the system architecture. So you have a 32 128, 64 64, 64 128. So all those parameters are going to affect the scanning speed. So the calibration process is pretty much the same. So you still have the element check, wedge delay sensitivity. So there's another one that's called amplitude fidelity. So as you notice on the images here, so the best image is going to be the one on the left. And then the center, as you start decreasing the fidelity or the number of pixels, you can see that the signal gets degraded. So what we're actually looking at there is the side hole. You also have sensitivity, so the unit, depending on which are used to, both the gecko and the mantis have the ability to do TCG. So I'll show you how we go through the process. So these are 3-sided holes in a block. So we go across the block, pick up the signals just like in a regular phased array or TFM. So you go across the holes, peek out your signals, go across the entire area region of interest. So we stop. Reverse direction just to make sure that you picked up the signals. So then we stop, and then we select next, and then you can select a zone. So you have a zone box here. So you hit increase, or you hit plus, and adjust the boxes depending on the side hole that you want. So you can add up to, last week I was setting up, I believe, 12 holes. So, and it's gonna adjust the TCG for you. So as you can see on the image here, so we're going across the side holes, and we have uniform signal across the entire area. And let's go and switch over to the other screen. So this is the unit. So right now I'm connected to the LAN connection. So I'm gonna select the parameters here. So I go SEC start. So in this case here, so there is a setting where I can adjust the specimen parameters. So I can do plate, pipe. So right now it's the plate. So the sample that I'm actually using is, so let me switch my camera. So the sample that I'm looking at here, so those boxes that you see here is where the SEC is at. So we're gonna be testing that. So my settings are already set up just to instance for saving time, right? So the thickness of the piece is actually a quarter inch, 0.25 inches. So there are you can adjust or at least enter the parameters for the weld if you have one. You can also have material, adjust the material. So I'm gonna hit OK in this case. So in this case here, you can select the Pro. So you can see on this, there's a list of most of the manufacturers that are out there in the industry that manufacture pros. So right now we're using the M2M G1, and it's a 10 megahertz pro. So you can go through the list. So there's no guessing what the parameters are. So they're already inputted. So you have the wedge. So I can input the wedge, same thing. So you have M2M. So I'm using a G1, I36, and then I36, I stands for incident angle 36. So I hit OK, and then it puts the parameters for that. So here's the other thing. So I can choose the pro reference, and then I can go angle height. So what this actually does is it calibrates the wedge delay without using a side drill hole. So the only thing that you have to do is pick up the signals, make sure you have a uniform signal across the screen, hit measure. As you can see, the incident angle was originally 36 degrees, but now it's 34. So that's good. So you can actually calibrate the wedge across the entire wedge. So I'm gonna hit OK, and this is where, so you can also enter in the values for, say you're using a gyra, echo scan. So right now I'm using a string encoder. So I'm gonna hit OK. So it inputs the parameters. You can also calibrate the thing. So one thing that I have here, so that's my area of interest. So that, as you can see here, so you can adjust the area of interest that you want. So I can hit compute, and it's gonna adjust it. So I'm gonna put some cupping on this thing. So you can see as I'm scanning it, so if there's some parameters that I want to adjust on the fly here, so then I can adjust them here without having to go back and switch back and forth. So that's the good thing about this software. So there's different modes that I selected. So right now on the setup that I did TT, TTT, TTT. So I have 4 different groups on this thing. And also I also have the PWI. But you can adjust a lot of parameters with this thing. So if I go to TFM options, so there is a fast option where if you want to go faster. So if I hit this icon up here, it's going to tell me that the maximum scan speed is going to be, it is 1.6 inches. So you can do that to see if you can increase the scan speed. So you can see here, the number of pixels that I have is going to be 24,000 for that area of interest. So I hit next, edit. So right now I'm doing a 1-line scan because I'm using the encoder. So the area of interest, or at least the scan area is going to be 4 inches. So I'm going to start at 0, scan end is going to be 4, and the step is going to be 0.039. So it's going to record every 39,000. So it's gonna take a slice of data. So I can go to my displays. So you can see right now I'm gonna set up an A scan. T scans is pretty much like an S scan for TFM. D scan is a side view. C scan top view. So I go edit. And then so one thing that you can do here is I can create a folder. So this is coffee. Hit OK, 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 and then so that's the data file I want to save. So it's gonna save it into that folder instead of having to find the files that you want or that you inspected. So when I set up, let's go and view all three of them, all four of them in this case. So notice what we have is there's so many parameters that we can adjust as far as the different modes for TFM. So there's TT on the left. The one next to it is TTT. And then we got TTT and then TT. So let's go and go through this thing. So as you can see on the image here, so you can see as I'm adjusting it on my piece. So you can see there's a tip on one of these cracks that we see here. So I'm actually gonna put more coupling on this thing. Let's go and do a scan. So I'm gonna reset the encoder here. So it starts at 0. So I'm gonna hit play and I'm gonna scan. So we'll go back to the other display. So I'm gonna reset this thing again. So I'm only gonna scan 4 inches here. So once you reach the distance that you specified, it automatically saves it or automatically stops. So I can hit stop and save, and then that's gonna be SCC. Hit OK. So then it goes automatically into analysis. So I can go across this thing. So there's cursors that I can choose. So I got view options. So I can hit this cursors. So we'll go distance. So notice as I go across this thing, so you can see that's where the crack is. So you can see the tips. So right now the gain was 76 dB, right? So one thing that I have on the equipment is I have the ability to increase it by up to 40. Now if a signal is saturated, one thing that I can do is actually drop it. See that? So you can decrease it minus 20, or minus 40, I mean, maximum. So one thing that I can do is, so that's my thickness was a 1/4 inch, right? So we'll go depth. So I know the indication starts at the top, so I can put a reference cursor there and then peek it out about right there. Hit measure. And on the screen, it tells me that the depth up here on the A scan. So you can barely see it, but so the depth is going to be 0.065. So one of the things that we did with the sample here, so this is a real life sample, right? So we actually scanned it with the ready equipment, and it would actually coincide with the height. So they all work together. So here's another thing that we can do. So we'll say that I want to measure the distance. So I'm gonna go distance. So I can put a cursor there. So we'll go up. See, my indication starts there. So I can move this cursor to depending on where the indication stops. So I can go here, measure, and then lock it in. So then it tells me the distance over here on the bottom right. So the distance is going to be 0.669. So you can add the indication to the report. So you have a gate adjustments. You can adjust the offset. So the other thing you can do with the software is you can do automatic sizing. So you can do +6. So you can choose a parameter. So if your procedure says -20, you can adjust it to that. So you would choose your area. See, I want to adjust it there. So it automatically sizes the thing. And then, so you can see I have 3 indications here. So one of the things, the other thing that we can do is we can take a screenshot no matter where you're at. So you can take a screenshot and say I want to do SCC. So I hit OK. Add an indication to the indication number 1. So I hit OK and it adds it to that indication. So the other thing I can do is if I'm doing a dead element check or wedge delay calibration or TCG, and I want to put that into the report, so I can actually take the screenshot wherever I'm at. So I can take the screenshot and then say this was a TCG. So I hit OK, add the picture to the report, I hit OK. So this is where I'm going to select the report. So notice it puts transducer, scan setup, ultrasound setup. So it goes through all the parameters. So you can see there, inspection data, shot number 1, indication number 1, number 2, number 3. So I didn't have any pictures for number 2 or 3, but so you can see, let's go and go back. So the other thing that we can do, so you can export the report as a PDF or Excel. So I haven't seen too many equipment be able to do that. So a lot of people like that feature because most companies generate their own report, right? So one thing that it'll export the indication table with the readings, and it also it'll export the pictures that we saved. So it'll save the pictures not as a bitmap, a BMP, but it'll save it as a PNG, which the file, or at least the size of the indication, won't get distorted, so the indication won't get distorted. So if I want to go to new scan, so I hit new scan, so I'm going to hit no. So I'm actually going to go, so I want to go back. So I'm going to go TFM 4, so that's the PWI, so that's good. So I'm going to scan some, I'm going to go live and see what we get with some other ones. So as you notice on this thing, so you can see the tips on these signals. So you have the option of choosing the cursor. So that's shot. So notice there. So that looks pretty good. So I also have some other cracks in here, so we'll try to size these. Some of these are too tiny. So one of the things that I have talked to some people, and one of the things that I heard was that phase array wasn't able to size some of these indications. So that's the difference between phase array and TFM. So if you have a diffracted signal coming off the tip signal, sometimes it won't come back too strong if you're using a regular phased array. But if you use the TFM, because it's receiving with all the elements, so you can see them a lot better. So there was one indication where in one of the pipelines, somebody was saying that it took them about 30 minutes to scan because they couldn't find the tip signal with the phase array, but we were able to size it in about 45 seconds. So as you can see here, so there's a very tiny signal here. So that's the tip. And then we know that it starts at the bottom here. So I can put tip. So my cursor starts here. So that's where my tip is. And then lock it in. So I can put the other cursor at the top because we know it starts at the top. About there. So you can see on the screen the height is only, we'll go here. Let's go and verify that thing. It is fairly short. But you can always get rid of the cursors if they kind of get in the way. Let's see. So we also have a workshop coming up next week using Capture 3.2 for corrosion mapping. So I think you'll like some of the features on the new features on the for corrosion mapping. So you can see the images here. So another thing I wanna mention on this is the fact that, so if you use TFM versus PWI, so if you notice that if I switch back and forth from that first TT to this other TTT, which is the one on the far right is gonna be the PWI. So if you notice the gain difference, so the gain is gonna be 76.1 versus 54.1. So it's a lot less gain because you're pulsing more elements. So in this case here with the PWI, I'm firing the 32. So with the TFM, I'm pulsing one at a time, but you can see they're fairly similar. But I hope you learned something, and just watch out for more stuff. So there's a lot of features that we can do with this equipment. I appreciate the time that you took, your coffee break. Your boss might be wondering where you're at. So let's go and finish this thing out. I appreciate it.